Hello, everyone. Welcome from Jing in Santa Monica. I finally got back. Everything looks good, and my colleague she sent me that balloon. Welcome home. I feel so, I'm loved. It's the feeling of home. You have people you love, and also you also have people love you. As long as you have those, that's home. So Santa Monica is also my home. In China, I have my parents, my grandparents, but here I have my friends and I have you.
Oh,
Okay, yeah, so I feel so good. Yeah, but I spending my whole day fighting with the jet lag and also cleaning a lot of things. Okay, all right, no worries. Last time, actually, I should thank Brian. Brian asked me this question. I think most of you will have this question. How should I start my project? I have this idea, right? I see you post that on your on our discussion board, and all of you actually have an excellent idea. Okay, so you can see in the past 3 weeks, I guess, or 2 weeks, well, our assignments actually are guiding you to finish, to start and working on this GIS project. First, I ask you to, the previous week, the discussion, I asked you to frame a spatial question, right? So that's the number one step you are going to do in any GIS project. Okay, ask a question about our space, about our patterns. What's that look like over the geographic space? Okay, and well, the next step is, well, GIS is not just mapping, right? GIS have a huge part that is the spatial analysis, which is powerful, which allows you to see other people's can't. So that is on Monday when I was still in Dubai, we have that demonstration and we have that lecture. Okay, so in this week, I ask you to think about what kind of questions you can ask. We have 6 big types, right? So on our lecture slide, you have those 6 big types. And then you will, maybe you will ask question like relationship, right? Cluster, the patterns, and why, right? Okay, so think about this. And after that, you probably have the third question. How should I do that? For example, let me share the screen with you. Here we go. All right, okay, I have my Pro. Okay, let me delete this. Nope. Okay, so I changed the symbology of my school and our oil and gas fields. Okay, so you can see here, well, I'm pulling in the data. I changed the, the projection to NAD 1983 UTM for LA 11 North. Then I go back to see my question. I want to know, okay, so within 1 mile buffer of each school, okay, I want to count, for example, our public or private school, okay, I want to count how many fields, okay, I want to know how many fields within 1 mile buffer of each school. Okay, so I'm like visualizing my output. Okay, so let me share the screen, share the whiteboard. Okay, so the question is, I want to know for each school, how many within, how many oil and gas fields, okay, are within its 1 mile buffer, right? So this is my question. Make sense? Are you with me? Yes. Okay. So then, double A's, delete this. Okay. So then I need to picture what's the output for each school. I have this count, right? Okay. So my output probably is a table. Okay, that's the attribute table of my school. Let me draw Okay, you notice the attribute table, right? I have a lot of columns. Okay, and I have this new column that is number of school, a number of oil and gas fields. For example, that's just the, let me redo that. Okay. Text, okay, number of oil and gas fields. Make sense? This is each school. For example, the school ID. Okay, for number 1, I count within 1 mile buffer, I have, 2. Okay, for number 2, school, I have, 0, nothing. Okay, for number 3, and so on. Are you with me? Yes? Okay, so picture your output. And then you need to think, okay, how can I achieve this? Right? How can I count? Well, this question sounds very simple, but it involves 2 steps, right? Okay, what we have now? We have school, right? We have school. What else? What the other layer is ready with is what? Is oil and gas fields. This layer is ready, right? But we don't have buffer. We don't have buffer. So then we should build buffer. That is your spatial analysis, okay? At this point, you need to look to our lecture slides, okay? To take a look at all these tools, which one you can use to build a buffer. Then that's your buffer too, right? Make sense? Okay, and then use that buffer, I can count how many, fields, how many oil fields in it. Okay. All right, so let's do this with Pro. Let's do this with Pro. Okay. Let's see, stop share. Okay, let's new share. Are you with me? Any questions? Okay, all right. Okay, so let's use that. Let's use Pro. Okay, so you can see, well, I can rename my layers. This is oil, gas fields. Okay, and this one is public school. Okay, let's use public school first. Okay, well, first I need to build a buffer. Okay, you know where to find it. That is in the tools. Okay, and you just build a buffer. Right? Okay, and you just use input and output to fill that out. Last time we demonstrated this already. Okay, but here I want to show you another way, which is a advanced way or a little bit fancy. Let's build a model. Let's build a model to do this. Okay, so in ArcPro, there's a very nice tool. It's called Model Builder. Okay, where it is? Right here. Okay, let me annotate. Model Builder, which means, well, you can use this one to build a model and to run that as many as you want, as many times as you want. Okay, so if you click on this tool, okay, you basically just have the white, paper, okay, empty blank paper, and then, well, you build your model. Any model. Remember what is spatial analysis? That is a process, right? You have your input, you have your output. Okay, maybe I need to pull out my slide. Let's see. Give me a moment. Okay. Change this. Come on. Here we go. This one. Okay. So let me remind you what is geoprocessing. Okay. So you can see it's a sequence of spatial operations. Okay. And for each operation, you have your input, you have your output, and you chain it. Okay, you can see this output can be the second operation, the input, and so on. So this flow chart actually is your model, and you can use Model Builder to do that. Okay, to help you, be clear what you need to do step by step, which I think is very useful. Okay, all right, so let's kiss. Keep it simple and stupid. Let's do that step by step. So if you think, how can I do this? You want to do that all at once, you will definitely overwhelm yourself. Okay, so let's do that step by step. Okay, so this is our model builder. Do you see my model builder? Yes. Sandy, do you see that? Yes. Okay, so here, let's first save it. Okay. Save. Do I need to rename it? Okay, so that's in my toolbox. Okay, you can name it as model 1, or we can give it another name, LA Urban Oil and Gas. Okay, model. Okay, let's just name it this. Okay, and later when you go to your, let's see, your view, and you go to your catalog view, and you will see your toolboxes, and you have these toolboxes, you will have this model. Okay, you'll have this model. I need to refresh, I guess. Yes, here we go. So you can run that many times. You can redo that. Okay, so then that is an empty model. For any model, remember, we have input, we have output. So the first step we need to do is to do what? Buffer, right? Okay, so our input is what? Input is public school, right? So basically what I just did is to drag this layer and drop it on our model builder, the page. Okay, so you can see I have this oval shape, that is our input. Okay, and then we have our tool, right? That tool need this one as an input. So you go to geoprocessing, and you can see I have buffer already here, but you can search. Okay, so you can drag your buffer here. Okay, you can see this is your buffer. Okay, this is your buffer. Let me put it here, make it pretty. Okay, and then I know this one is this one's input, is the buffer tool's input, right? Okay, very intuitive. Okay, you just click on this oval shape. Okay, hold your mouse, hold your left key, and you drag an arrow pointing to buffer. Okay, pointing to buffer. Okay, release your mouse and it will ask you. You use that as input features or other things. Okay, it depends on different tool. Okay, so input layers. Okay, and then you can see this buffer is grayed. It's grayed, means it's not ready. When it's ready, it will become colorful. Okay, so why? Because you just specify one parameter for this tool. Okay, so let's double click on that. You can see you will launch this tool, but oh, I want to resize this one. Okay, but you need to specify other parameters to run this tool. Okay, so you can see this is my input layer. Okay, and the output layer, of course, I need to rename it, right? Okay, so you can see here by default it will save to my project geodatabase. So that's why in last week we demonstrate how to start your GIS project in ArcPro. It's very important at the very beginning you specify the location. You don't have to do that later. Okay, so that is a default location. Okay, let me mute people. Cameron, can you put yourself on mute? It's a little noise there. Okay, here we go. Okay, All right, and then let's rename it public school. Okay, like 1 mile. Always name your layer with a meaningful name. Okay, for example, you use buffer and, you know, to include the buffer, the width is very, very helpful later. Okay, and here linear unit and then value number 1, but I need to change miles. Okay, and we need to use planner because it's just LA, it's very local, small area. Okay, and then dissolve, let's don't dissolve because for each school I want its own buffer, right? We don't want to dissolve it. Okay, so here let's click OK, and you can see your tool will become yellow, okay, but you can change the color, of course. Okay, and your output, resize it. Your output will become the layer you put the name in your tool. Okay, I see a chat. Oh, okay, no worries. Okay. Do you know how to build this? Okay, sort of. Okay, so let's keep it simple. Let's just use this buffer. Later, I will change my tool. Okay, and then you can see everything become colorful, right? Okay, everything become colorful. And let's go to this model builder. Let me clear my drawings. Okay, and then you can validate. Okay, you can validate before you run. Okay, so let's validate. Okay, looks good. Nothing happened, right? And then you just hit run. Okay. All right, it's done. It's done. You can check this box and this box will disappear. Okay, but you can see, close. Okay, let's go to our oil and gas fields. Let's go to our add data, input, no, map. Okay, so you can see, let's add our data, add data, add data. Okay, that will be in your project data, your home geodatabase, okay, right here, and then public school 1 mile buffer right here. Okay, so you just add it, and you can see for each school. Let me turn off these fields. Okay, for each school, let's go to closer. Okay, for each school, remember, for example, this one. Let me turn off this one. Turn off this facet. Okay, you will have your own buffer. So for example, this one belongs to this school. Okay, does that make sense? Okay, all right. Okay, then I want to count, right? Let me turn off the school. Okay, so now you know those bubbles, they're buffers, right? They're buffers. I want to count. I want to count for each buffer, how many oil and gas fields in it. Okay, how many oil and gas fields in it? Okay, what should I do? Right? I don't know. Let's go to our lecture slides. Okay, you know, GIS, vector data analysis, there's only, several categories, the tool, okay, you can use to answer all the questions actually, okay? So, extract is get part of the input layer, okay? It's for our question, should we use extracting all these tools or no? Let's go through that. I don't want to give you the direct answer, right away. It's extract? Probably no, right? Extract is just like what? Like, let me show you this. Okay, for example, let me zoom out. Okay, for example, let's turn this off. Let's turn on our private school on. Want this? Come on, computer. Okay, here we go. So you can see extract is get part of your original data. So you can see our private school, those blue icons, okay? That is for entire LA. That is for entire LA. But for our project, we just want the school within LA County. Make sense? So in that case, you want to get part of this larger data set, then you need extract, right? You need extract. So that is, get a subset of your initial data, okay? So you can see here, what are the extract, the get part of the input layer? Well, you can clip. That's the tool name, okay? Clip basically is like a cookie cutter. You just cut it like this one, okay? Like this one, you just cut it, okay? Or you can just select. Select, you basically just highlight, okay? Pick them out, but they still belong to the original data layer. You need to do one more step to save the selected features, okay, to a new data layer, okay? Or you can split. Split is this, okay? It's like a cookie cutter, but you have multiple cookie cutter with the same size or different size, okay? Actually, it works, okay? Just separate this, the input into different sections, okay? And each of them will be one layer, okay? I can share this experience with you. My PhD thesis, I use this tool. Because my study area is one province in Anhui, in China. It's called Anhui Province. Okay, let me go there. Google. Isao, can you mute yourself? Okay. Okay, so this is Anhui. This is Hubei. This is Hunan. Anhui is here. Okay, sorry. Menu. Don't want the. Just want the satellite. Okay. Ah. Okay. Basically this part. Oh, annotate. Drawing.
Professor Jean?
Yes, it is this huge part.
Oh, we only see the map that you.
Oh, sorry, I need to share. Sorry. Do you see that now? Yes?
Yes.
Okay, good. So basically is this part. It's a huge province. Okay, so basically my computer at that time is too slow. I cannot process the entire thing. And also my project is to map out the soil in this area. So I basically use watershed. There's a lot of rivers here. Yangtze River is here. This is Yangtze River, you can see. Okay, this is the biggest river across this is Wuhan, across the province. So I use watershed. For example, is like this, different polygons. I cut the province into different sections, and for each section, I build my model. Okay, so that is when you use split. But anyways, I split it, I think, into 9 big watershed. I have 9 layers, and I have 9 models for each layer. Okay, so that basically is the extract tool. Okay, but it's not in our case, right? It's not in our case. So let me stop share. Okay, stop share, and let's go back to our share the screen for Arc Pro. Okay, So, you know, I want to, let's remind ourselves, I want to do what? I want to count. Here, let's go back, okay? I want to count for each school how many oil and gas fields in it, okay? Within each buffer, okay? By using this proximity tool, we get the buffer already. We have that layer already. So that now the problem, the question becomes, okay, within each buffer, I want to count. I want to count how many fields, okay? So which one do you feel is right? Is proximity or overlay?
I think proximity.
Why you say proximity?
Proximity.
Oh, someone was saying something. I was just gonna say that it's because we're trying to figure out how close the oil fields are to the public schools.
Right, right. You can see we want 1 mile buffer around each school, right? So we use buffer to build polygon already. That is proximity. So we have that information. Now you want that buffer, this proximity information, combined with oil and gas fields to generate another information, right? So we consider this already. So it's not proximity. Actually, it's overlay. We want to use 2 data layers, right? Proximity, you just need one. You just need your buffer, the central line or polygon or points. But overlay is able to help you combine 2 data layers. Does that make sense, guys? Okay, so let's take it slow, okay? So you can see then which one, right? Definitely not erase, because erase is like an eraser, okay? Which one is the eraser? Here is the eraser. So you can see this is my eraser. I just erase the one overlapped with this rectangle, and then I just get the outside, right? Okay, and then, well, then let's go back, okay? Identity is also not what we want. It sounds wrong, right? Identity actually give you, let's see, give you the unique combination of different, you know, the sections, okay, from 2 different layers, okay? So actually here we need to use this one. Let's see, okay, spatial join, okay? So you can see here, let's see, spatial join, okay? This one is a little bit challenging, okay? So you can see spatial join actually join the attributes from one feature to another based on the spatial relationship. This is the key, guys, because we want those buffer, we want those oil fields within the buffer, then we can count it, right? This spatial relationship within is the key for this analysis. Does that make sense? Okay, so that is called spatial join, and the target features and the join features from the join features are written to the output feature class. Okay, so basically you will combine those the attribute table of those 2. Okay, and also you can do count to the joined feature class. Okay, so let me show you. So for example, let me show you this. For each well, you can see, for each well, I want to know within 1 mile buffer of this well, what is the soil type? Sounds similar, right? Okay, and I want to know, okay, within 1 mile buffer of this river layer, how many wells are located? Okay, so that is our spatial join. Okay, so let's go back to our model builder. Okay, so you can see, oh, I have this buffer built up already. Okay, and I need to use another tool. Okay, tools, you can search here. That's called spatial join. Okay, spatial join is here and put it, oh. Okay, put it here. You can double click, add it here. Okay. Okay. Oh. All right. Okay. So let's put it here. Make it pretty. I want to move it. I want to move it. Okay. All right. So you can see now we are chaining those different tools. Okay. So now spatial join is great because we need this one as the input, right? So as the input, and it's target or join. I don't know. I don't know. So let's put it at target and let's see what does that mean. Okay. All right. So you pointing to the spatial join and then you can click on the spatial join. Okay. All right. So target features, what's that? Let's hover over this little eye and you can see. Okay. Target features required attributes of the target features and attribute from the join features are transferred to the output class. Okay, I know that's a join. However, a subset of the attributes can be defined in a field map parameter. Okay, it doesn't tell me anything. All right, so let's leave it there. And then join features required. Okay, so what is join features? The attributes of the join features are joined to the attributes of the target features. Okay, so basically this one, you want to join this join feature to your target. Okay, and see the explanation on the join operation parameter for details. Okay, then I need to go here. Okay, the join operation. Okay, where it is here. Join operation is here. Okay, so you can see here I hover over this little eye. This little eye. Okay, so you have two options basically. You have join one-to-one or join one-to-many. Okay, so let's read it. Let's read it. So join one-to-one. Let me copy that over. Make it larger. Copy. Okay, and make it notebook. Okay, all right. Is that large enough? Okay. All right, so you can see, let's read it. Join one-to-one. If multiple join features are found that have the same spatial relationship with a single target feature. Okay, it sounds like our case, right? Okay, within one school, the buffer, you may have multiple oil fields in it, right? Okay, if this is the case, the attributes from the multiple join features will be aggregated using a field map merge rule. Okay, so I will grab them all and merge them somehow. It's a rule, merge them. For example, in our case is what? I just want to count. Does that make sense? Okay, so then your field map merge rule should be count, right? Should be count. If it is, you know, you can also summarize. For example, you will have multiple like voting stations, okay, across LA. Okay, it's happening, right? Okay, and then with each voting stations, which is voting station, let me draw. Sometimes I just feel, you know, a picture worth thousand of word. Okay, so this is your voting station. Okay, and you have this 1 mile buffer. Okay, let's use maybe purple. Oh, let's use blue. Okay, you have this 1 mile buffer around this this station. Okay, and you have different district. You have different, you know, for example, zip code. Okay, around within this buffer zone. Okay, and you want to count for each zip. for each zip code polygon, how many people living in it, or how many, you know, different ethnic groups, okay, or social income, what's the average social income, you know, household income, sorry, okay, and then you want to aggregate them. For example, for population, you want to count, well, this voting station, okay, this voting station serve how many people within 1 mile buffer, right? And then your aggregate, the rule, the merged rule will be sum. Or age, I want to know the average age, then you can use average. Does that make sense, guys? Okay, so this is a one-to-one. So basically, you just add one more thing to your target feature, which is this buffer, right? Okay, so that also answers another question: which one should be your target? Which one should be your join, right? So in our case, the buffer should be target. We were right, right? And then the join feature should be the oil fields. Does that make sense? Okay, as opposed to this join one to many. Okay, so you can see if multiple join features are found at the same relationship, okay, with the same relationship, the output features, okay, will contain multiple copies. So basically, if for each, you know, oil and fuel, for each school, the buffer, okay, you have one school, I'm sorry, one oil and fuels, you will have one buffer in your output. If you have another one, you have another output, which is super confusing to me. So let's just don't use it. Usually we use this buffer spatial join. We actually want to aggregate the information, okay, to our target layer. So we usually use one-to-one. Does that make sense, guys? Brian, Lauren, yes? Okay, good. So this will be the, you know, every semester, this is the most confusing part. So let's take it slow, let's digest it, okay? All right, clear all the joins. Now I know what this tool is doing. So my target layer is the school 1 mile buffer, okay? And join features should be oil and gas fields, right? Okay, this one. And then output feature class, okay, spatial join. You can also, you know, put it as count, okay, count. Okay, join one-to-one, keep all the features. And you can see this is a match operation, okay? This is your spatial relationship. So we want to within, we want within, okay? We, let's see, probably we have the search layers. Join count, oil fields, within, what's wrong, what's wrong, what's wrong? Should be within. The features in the join features will be matched if a target feature is within them. Okay, then we should put contains in this case, right? Okay, target contains the joined. Okay, let's do contains. Okay, oh, okay. Then we should switch, right? Okay, let's see. Hover over here, and you can see contains. Contains. Okay, the feature in the join feature, the features in the join features must be matched if the target contains them. Okay, target buffer contains them, right? Okay, and then for within is, let's see, within is the features in the join features will be matched if a target feature is within them. So I want the oil and gas fields within the buffer. So oil and gas should be target. It's weird, guys. Don't be overwhelmed here. You can see Jing also feel confused. But anytime you see a like little X over there, double check the meanings. Okay, you will make sense of that. Okay. All right. So let's see. So within this Java, I think, yes. Okay. So within contains should really sounds really similar to me. What's the difference? Java and anyone feel confused, contains and within they are opposite. Okay, so you can see here is within. The feature in the join features, let's read it, guys. Let me copy that over. Okay. Within, the feature in the join features will be matched if a target feature is within them. Okay, it's within them. All right, so ultimately, I want to match the oil and fields within the buffer. Within the buffer. Okay, so you can see within them, then the them should be buffer. Okay, and oil and gas fields should be target. Should be target. Make sense? Okay. And it's opposite to contains. Okay, so let's copy contains over. Hover over here and contains. Contains is here. Okay, copy, bring that out. Okay. Okay, contains the features in the join feature will be matched if a target feature contains them. So I want buffer contain the soil. I'm sorry, contain the oil and gas fields. So buffer should be your target, right? Okay, anyways, I want to show you this because, you know, don't feel bad. You feel, oh, Jing, I just cannot figure that out. Okay, take it slow, and think that ultimately you want to achieve what? Okay, step by step, and then you will see, oh, my tool can run. Okay, and here, this is a warning, datum conflict. See, this is a very important thing in spatial analysis. Okay, when you do the spatial analysis, good practice, best practice is to unify the coordinate system of all the data layers. Okay, so you can see here my oil and gas fields probably is WGS 1984, and for the other layer I think it's NAD 1983. Okay, so anyways, I just leave it there. Okay, because it's a warning, no big deal, I think. Okay, just do that. Okay. So search radius basically is a parameter to help speed up the processing process. Okay, so when you hit run, what it will do, you know, it will search, go through all the oil and fields, calculate, you know, the relationship to your buffer, all the buffer, okay, and then to count to see whether it's contain or within, okay, either way or not. So if you have, think about, you have a lot of buffer, you also have a lot of school, right? The processing, the time will be long, especially when you have a very smaller the computer memory or processing power. Okay, so within search radius is from your school buffer. Okay, I search certain distance. Okay, I search this certain distance, but it actually doesn't matter. Okay, it doesn't matter here nowadays. Okay, so you can see here. If, oh, don't crash. Oh my gosh, it's crashing. No. Okay, so you can see if you count, if you want to, you know, count how many oil and gas fields, actually you don't need to specify the field map. it will automatically give you that number called join count. But if you want to, for example, give you, let's see, do we have a, if we have a population here, we don't have population. Okay, we don't have population here. If you have a population, you can choose for certain fields, you use sum. Okay, so for example, let's see. Township, we don't have population here. Yeah, so if let's pretend this one is population, and you can specify this as a sum. Okay, as a sum. Okay. Do we need count? We don't need count. We don't need count, I think. Let's try. Okay, it's easy code. Let's do this. I think it will give us a join count. Okay, click OK. Okay. All right, so you can see when you build this model, okay, you will bring in another data layer, and then it will produce this public school. Okay, public school, you can see spatial join this layer, but you will have an updated attribute table. Okay, make sense, guys? Okay, all right, so let's verify. Okay, looks good. Let's run. Okay, so you can see when it's executing, the tool will become red. Okay, succeeded, and it's done. Okay, so you can see here. Let's add our data. Okay, model builder. I want to go to map. Okay, let's add our data, and let's go to spatial join. Where's my spatial join? Data sets. Join table, where it is. Okay, so if you cannot find your database, you go here, databases, you will have your home database. Should be here. Let's see, let me refresh. I probably need to refresh. Yeah, spatial join count here. Okay, so you can see still a polygon. Okay, let's add it. Okay, let's turn this one off. Turn this one off. Okay, and then let's see. Okay, so you can see this one basically is identical to your buffer. Where's my initial buffer? 1 mile buffer. Let's add the data, database, 1 mile buffer. Okay. Let's use this one, change the color. Okay. So I want to change the color for this initial one. Come on, computer. Okay, let's change this rose color, apply. Don't know why it's so slow. Okay, here we go. But those two data layer, they're identical. So basically, you don't, in terms of geometry, you don't draw any new buffers. But you for open this attribute table. Attribute table of your buffer spatial join. And you can see you will have this join count. you will have this join count. Okay, and for each polygon, for example, this one I have 49, guys. Let's go there, zoom to. You can right click on the block in front of this row, and you can go here, zoom to. Okay, where it is, super slow. I think it's probably in Culver City somewhere. Come on. Okay, let me stop share. I think it will speed up. Okay, here we go. Okay. Let me turn that off. Okay, right here. Share the screen. Right here. Do you see it? Okay. It doesn't look like we have 49, right? Or we have a lot of clustered here or here. You can verify that later. Or yeah, I don't, maybe here we have a lot. Anyways, this is your spatial join. This is your spatial join. Okay, so you can see within the buffer, I can count how many fields in it. Okay, so maybe let's verify within another one. So let's see, open attribute table, and let's go to the first one. We have just 3. Okay, zoom to. Okay, here we go. This one is much better. Okay, share the screen. Okay, do you see it? Okay, we have 1, 2, and 3. This one is on the edge. Okay, this one is on the edge. We have 3 oil and fields within this school's buffer. Okay, this school probably have a lot. This one probably have a lot. This one. Okay. Anyways, any questions by far? Okay, so I see one question in the chat box. Okay, Grayson, are we going to learn this whole process, buffering using QGIS? Yes, I'm going to do that. Okay, all right, so here, if both sides of your join were polygons, Javi, don't know, what do you mean? Would the join happen if they overlap? Not entirely. Remember, Javi asked this question. Javi asked this question. If the buffer overlapped, for example, this one, okay, and this one, the neighbor one, they overlapped, do we double count in this case? Yes. In this case, yes, because for each school, I want to know its own, within its own buffer, how many schools. I don't want other school, the buffer, you know, contribute to this information. Okay, so that's why when I build the buffer, you can see a lot of overlap. I don't want to merge them. I don't want to merge them. I don't want to dissolve them. Okay, if you choose to dissolve, that actually can get you all the area. Okay, within, that's all the school 1 mile buffer. Then in that case, the number of the oil and fields won't count. And your output data layer, you just have one polygon. You will dissolve all the bubbles here as one polygon. Okay? Yeah. Okay, so quickly, let's go to QGIS. I have this ready. QGIS, same thing, guys, same thing. Okay, so here, let me clear my drawings. Okay. All right. Okay, so I add the data layer. Okay, so you can see this is our oil. Let me change the name. Properties. Okay. this one is oil and gas fields. So you can change the name here. Okay, make it more, make more sense. Okay, so you can see. Let's check this one off. Okay, so you can see I want to do the same thing. Okay, I want to build a buffer, and for each buffer, I want to do a spatial join. Okay, so in this one is coordinate system. So where it is in the processing, okay, you will have this so-called graphical modeler. Graphical modeler. Okay, for QGIS users. Okay, you click on that, pretty much the same thing. You have this, empty space. Okay. I cannot resize this part, but you can see here you have two tabs. You have two tabs. One is inputs. It's just like our input data layer in ArcPro. Okay, model builder, and you have your algorithms. Here, algorithms, actually, they are your tools. If you don't know the tool or you don't know where the tool is, you can just search here. For example, buffer. Okay, for example, spatial join. Okay, spatial join. I think here, that is called join attributes by location, is this one. Okay, oh, I'm sorry, it should be this one. Join attributes by location summary, because we want to summary the number of oil and gas fields within the buffer. Okay, but let me quickly show you the buffer. Okay, so basically here, okay, for our buffer too, okay, you can double click. Okay, you can double click, open it. Okay, and you can see here you can input your data layer already, and then later you can just hit OK, drag it to your model builder. Okay, or you can just put it here. Okay, buffer, I don't know, I just want to use it. Okay, you just drag and drop to your canvas. Okay, empty paper, and you will open the same thing. Okay, double click or drag. So here you can see your input data layer. Okay, my input, I can specify certain input data layer. It's just like what you do in ArcPro. Okay, so the input will be what? Oil and gas fields. Yes. Okay, and the distance here. Sorry, input data layer should be school. Okay, let's do that at school. This one. Okay, school. And one, you put one here. Okay, because I want to build a 1 mile buffer. Well, later you need to, for QGIS, you need to do the projection first, because this one, it will use the distance, the unit, okay, of the coordinate system of this data layer. Okay, so before we do this, you need to do the projection to change the projection, the coordinate system of this layer. Okay, and the segments basically is how many buffer you want to build. Okay, each one will be increase the 1 mile. Okay, here we just want to build one. Okay, and you can do the type. Okay, join type. Okay, you want to round and then meter. You pretty much just leave it there. Okay, just leave it there. Okay, by default. And here this is your output data. Okay, so you can see, let's buffer out, school buffer. 1 mile. Okay, and just hit OK. Okay, so you can see for this one, okay, I needed my input. I know that input should be here, right? It's a what? It's a vector data layer. Okay, so you just drag your vector data layer here. Okay, and description is my public school. It's not the layer name. Okay, geometry type is a point. Okay, or you can use any geometry type. Okay. Okay, and then you will use this one as the input. Okay, Oh, sorry, this one, you need to go here. Model input, okay? Model input, public school, okay? And click OK. All right, okay? So this public school, let's see. Okay, so let me answer the question later, okay? All right, so then that is your school, okay? That is your school layer, and then you put it here, okay? Then you can, let's see, run the model, okay? And it will ask you in QGIS a little bit different. You can just specify the data layer you are going to use like I did before, but you can also, when you build this model, double click on it and put this input layer as model input. That is a parameter, you put it here. And later when you hit run, QGIS will ask you, okay, Jing, which data layer is public school? And then you can specify that layer. Does that make sense? Okay. All right, okay, so click OK, and then I need to run, and you can see here, and which layer you want to put it as buffer, right? So you can create a temporary layer, or I want to save that to file, right? I want to save that to file, for example, here, GIS, data, project data, okay, to this folder, okay, shapefile, okay, so school 1 mile buffer, okay, hit save, okay, and you can just hit run. Okay, and you can see I probably need to change the coordinate system. Okay, let's save that first. Okay, parameter name. Okay, I need to name it. Okay, that's my simple buffer. Okay. And save it. Okay, save it to somewhere. Desktop, PC, teaching, 20, data, simple buffer, GIS. All right, and I save it. Okay, so you can see, oh, I probably, you can see here, this is a lot of mistake here. So number one, the shape is wrong. I probably need to use the round, not square. Okay, let's go back to our model. Let's see, double click it. I put it as round. It's not square. What's going wrong here? No, I don't want to dissolve. I don't know, to be honest, why it's giving me the square. I put everything as round. Let me figure that out. But this is how you build the buffer, the tool, using the graphical modeler to build your model, okay, in QGIS. But same idea, guys, same idea, okay. I think here you can also see the size of those buffer went wrong, right? It's too large. Definitely QGIS, you need to convert it. Okay, you need to convert it to do the projection first, and then do what? Do this buffer. Okay, because when you specify your one here, okay, the size, sorry, the distance, this one, it use the coordinate system of your public school. Okay, so what is public school? This layer. Let's cancel this. Public school should be this one, right? Okay, so you can see properties. You go to here. Source. Okay, I use this NAD California Zone 5 something. NAD sounds to me that's still like longitude and latitude. It's not UTM, it's a datum. So you put 1, that means 1 degree. 1 degree at the equator is about like 111 kilometers, something that long. Okay, if you move that up, it's still, you know, a big size. Okay. All right, so here, that is a problem here. Okay, a lot of problem here. In QGIS, actually, I also suggest you do the same thing in ArcGIS, ArcPro, to change the coordinate system first, and then to do the spatial analysis. Okay. The good thing, the advantage of this, okay, is you can save it. You can next time you, for example, you mess something up. Okay, for example, 1 mile buffer, you want to change it to half mile, and then you can just easily change the settings in your model, and then you can just run that again. And another advantage is you can output, you can save it. Let's see, model, you can validate model. Let's see, save the model, edit, view. Let's see, for this one, which one is my Python? Here, this one, okay? Export as a script algorithm. So for people interested in Python, you actually can learn how you can use Python, the language, to code it up. Okay, to code it up. It's actually a very good way to learn Python, this you know, processing language. Okay, in ArcPro you can do the same thing. Okay, here ArcPro. Let's go to our model builder. Processing. Where's my processing? Oh, here we go. This is our model. Okay, and then you can actually, let's see where it is. Okay, export here. Okay, and then you can export it to Python file. Okay, Python file. You can also send that to Python window to just see it. Okay, just take a look at it. Okay. All right, so that's pretty much the same thing. You know, you can do that in QGIS and ArcPro So today the focus, actually, I want to get you, you know, familiar, understand the spatial join, because this one is a little bit confusing, a little bit challenging. Okay, most people have difficulty on this. Okay. And
Jane,
yes.
so I know we didn't have the coordinate system correct for the QGIS, but with the spatial join process, would you just go to algorithm?
Algorithm. Yes.
Yeah. We would go there, and then you would just find the spatial join out of those. You would type it in the same way.
Right. Exactly. So here you can see join by location summary. Okay. So go here, and you can see input data layer will be your buffer, school buffer. Okay. And join layer will be your oil and fields. Okay. Okay. And then fields to summarize. Well, let's see. That should be just a count, I think. Of course, let's not be joined. Model input, value, model input. Let's do model input. Okay. Yes. Okay. So this one is join count. Hit OK. See this one. Oh, come back. Where it is. Oh, here we go. Okay. So this one, let's see. 1 mile buffer. Join attributes by location, or that is, let's see, let's try another one. Base layer, join layer. Okay, sorry, I was confused. Okay, so it should be join attribute by location, not summary. Okay, and then you can see your base layer should be this one, should be 1 mile buffer. Okay, and join layer will be your oil and gas fields. Okay, and then geometry.
Why is it different? I thought for in ArcGIS we did join attributes by location summary. So what?
Yes,
was that?
That is why I was confused earlier. I think it should be summary, but it doesn't look like it's give me the similar thing in as in ArcPro.
Okay.
Okay, so let's try. Use to add. I don't want to add. Okay, create separate features for each matching feature 1-to-1. See, this one join type is 1-to-1. And discard which not be joined. Yes. Okay, so count. Let's try. Okay. All right. Okay. Show details. I changed it. Okay, let's start over. Remove. Okay.
Is it possible not working because we don't have the right coordinate system on? Or that would not really affect it?
I think it will affect it, but I just want to show you,
The steps at least.
Yeah, the steps to build it up. So
Okay.
oil and fields, base layer, oil and fields, fields to add. I don't want to add, or count. Okay, and then attribute only. Okay, 1-to-1. Yes. Okay, and then count. Join count. Okay. All right. Okay, let's run. Okay, for this one, parameters. Okay, school 1 mile buffer. Public school should be this one. Okay. Join count. Join count will be saved to file and count. Save. Okay. Why it doesn't ask me to specify the relationship, right? Huh. Let me go back. Let's do model input. Okay. And then okay, so it looks like it's different. Okay, so let's do spatial join. QGIS. Performing spatial joins. Let's see. Okay, which tool? Vector. Vector. Okay, capital. Okay. All right, which tool? Huh. Spatial. Okay. 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 See, it should be join attributes by location, right? Okay. target, join vector, intersecting. Okay, so why we don't have that here? Base layer, join layer. Okay. Model input. Okay. We don't have this. Join type. Okay. Yes. All right. So let's go back. Okay, I need a little bit more time to figure it out. So let me record a video to show you how to do the spatial join with QGIS Pi version. That one probably is the earlier version, but you can see we located the right tool, but we just don't know where to set up that parameter. So now that's the problem. Okay, so let me use after our class, let me figure that out. I will record a video to show you how. Okay. All right, so yes, so this is how to use QGIS model builder and also ArcGIS model builder to build a model to run. But you can see, I think the more important thing is to think through your questions. What are the tools to find the tools to solve, to answer your questions, right? Okay, so in the next week, our discussion, okay, I want you to, based on the question you have, to find a tool, okay, propose the tool you're going to use. And when you look at, I will look at your contribution, your response, and then I will correct you if I see any mistakes, okay? Yeah, think about it, how you run each tool, okay? Okay, so let me stop share, okay? Stop share. Okay, another thing I want your help. Okay, I want your help. So next Thursday, let's bring everything together. Let's bring everything together. From starting a question, okay, finding the data, okay, ask a spatial analysis problem, and then to find the right tool. Okay, so I want, and if any of you want to use your own project as example, okay, I can use that to demonstrate that to the whole class. And you will also see how you finish your project. And maybe you can also inspire me to do more things. Okay, so let me know if you want me to use your project as an example. Otherwise, I probably will use the election map or the oil and fields map. I don't know. Okay, all right, my apologies because I didn't try the QGIS, the newer version, so a little glitch there, I'm so sorry, but I will make a video to show you how to do the spatial join, okay? All right, so I see some of you have questions. If you have questions, please stay. Otherwise, I wish you a happy weekend and happy mapping. Bye, guys.
Bye, Professor. Have a good weekend.
You too.
Take care.
Bye-bye.
Bye.